Today we are starting our production and operations management class for the MBA second sem. Now we are starting network analysis. Network analysis starts with PART and CPM. We had touched this program in the class and then we are continuing it from there. Now PART is program evaluation review technique. Now this was used for the Polaris fleet ballistic missile project. Now in the US Navy, first this technique was used there. Now it is used for projects where the time required to complete the whole project is known. That is, the time required for the whole project is known, but the time required for time required for the whole project means the total time is set for 1 year, but you do not know how much individual jobs for the each individual jobs or activities will take. So this we have to develop the project network diagram. Now, once established, the time values are obtained for each activity, whereas and the time estimates are not obtained singly, but it is obtained by skipping around the network. Now, by skipping around the network, we mean there are 3 time estimates. That is the optimistic time, T0, the normal time, TM, and the pessimistic time, TP. Now, say there are 30 workers were interviewed, and we'll divide them into 3 groups, say of 10 each, and we'll take the optimistic time. That is the 10 groups will say how many of you can complete the work in the fastest time, in the smallest amount of time. That is be the optimistic time, the fastest time. They will answer 10 days. TM is the normal time or the average time, and and some people will say that say around 10 days they take them to complete, most likely time to complete a task with allowance for some unforeseen delays. Now, and TP is the pessimistic time or the slowest possible time. Some people will take the slowest possible time to do a particular task. Now, the fastest possible times means the person with no hurdles or complications will uh, no hurdles or complications will do in the no hurdles or complications will no hurdles or complications they will with no hurdles or complications will then no hurdles or complications when they will do it in worker. Hurdles or complication of analysis means says machine breakdowns, delays, and pessimistic time here means that the machine breakdown is with the individual delays will be there. Now, time estimate is that is TE is obtained the average time, which is and the calculated from the optimistic, the pessimistic, and in the normal time. Now, the average time TE, which is T0 plus 4 TM plus TP. Now, TE is the we know as the optimistic time, TM the normal time, or and TP is the pessimistic time. Then we calculate the TE or the expected time or the average time. Now, T0 plus 4 TM plus TP divided by 6. Now, T0 means optimistic time plus 4 into TM, the normal time, plus TP as the pessimistic time. Now, we have and the activity 1, activity 1 to 2, and then activity 2, activity 3, activity 4, activity 5, activity 6. Activity description, activity 1 to 2. We have T0 as 18 days, TM as 24 days, and TP as 42 days. Activity 2 is 1 to 3, means from 1 to from session 1 to session 3. That is T0 plus TM plus TP. That is T0 as optimistic time as 12 days, TM as 24, and TP as 36. Activity 3 as activity 3, and the one and activity 2 to 4, activity 2 and 2 to 4 as T0. The optimistic time is 2 days, the normal time is 3 days, and the pessimistic time is 10 days. And for activity 4, 5, and 6, that is 3 to 4, 2 to 5, and 4 to 5. Now, what happens here, we must see is that the T0 or the normal activity is 18 days. Say for example, we take only activity 1. T4, TM is 24 and TP is 42. So we have 18 plus 24 into 4 plus 42 divided by 6. Now we have the total, when we are dividing this, we get 26 days. The most beautiful example will be 2 for activity 3, which is given with the description as 2 to 4. And we have, say, 2 plus 3 into 4 is 12. 12 plus 2 is um, uh, uh, 2 plus 3 into 4 is 12. Means 14, and 14 plus 10 is 24. 24 divided by 6 is 4. So likewise we get the values. Now we have to draw the network diagram. Now you see that activity 1 to activity 2, it is 26 days. It takes 26 days to complete from activity 1 to 2. We describe the path as 1-2. So this is the activity bar. Activity 1 to activity 2 is 26. We see the TE, or the expected time. We only use the expected time in preparing the network diagram, and we see this as 23 days. Now activity 1 to 3, we can see is independent of activity 1 to 2, and we can start both the activities together. So activity 1 to 2 is here only 24 days. So however, activity 1 to 4 is only 24 days. However, activity 2 to activity 2 has 2 to 4 and 2 to 5. That is activity 3 and activity 5. So 2 to 4 it takes 2 to 5 it takes 30 days, as given 2 to 5 it takes 30 days. That is TE. We can see here is 30 days, and activity 2 to 4 is 4 days. The one we just calculated for activity 3, activity 2 to 4 is 4 days. So we have two arrows generating from there, that is activity 2 to 5 as 30 days, and activity 2 to 4 as 4 days. Now we have 1 to 3 as 24, and we have 3 to 4 as 16 days. Now activity 3 to 4 we take as 16 days. Now activity 4 is activity 2 to 5. Now final activity, now we know that any activity has got either a predecessor or a successor. That means the activity 2 has got a predecessor, which is activity 1, and activity 5 has a successor, which is activity activity 2 has a successor, which is activity 5. Activity 1 does not have a predecessor, which is, it is a start activity, and activity 5 does not have a successor because it is the end activity. So only the starting and the ending activity, in this case of this particular diagram, activity 1 and activity 5, they have either a predecessor and a successor. In case of all other activities, there is no predecessor and there is no successor. Now in these activities, we have to write the number of days in this manner, that is from 1 to 2 we have to write 26, from 2 to 3 you have to write 30, from 2 to, and this is the expected time, or TE. 1 to 3 you have to write 24, from 3 to 4 you have to write 16, from 4 to 5 you have to write 4, and from 2 to 5 you have to write 30. Now this is the actual pattern where we draw how we draw the network diagram, and how we draw the particular PERT network diagram. Now we'll continue this PERT network diagram in our next classes with the CPM, or the critical path method, which uses the path diagram to see the time that is required in completing a certain project, and we continue with that. But however, please remember this situation, as we're going to use the same diagram and the same problem in furthering our analysis for the critical path method, and how to calculate the critical path method by earliest time and by the latest time. Thank you.